Hello all, welcome to nETSETOS. Today in this video, we will have a look on the question based on flipping of binary numbers, which is very important in terms of competitive programming. Let's see the question first, which says given a binary string which represents the target state. Here we need to find out minimum number of flips needed to convert the same size binary strings with all zeros to target state. Also, it should cause the right bits to be flipped. Let's understand this with an example. Here we have 101 and initially we took all zeros. Here the size is 5, so we took zeros in terms of all 5. So as to make this clear, I have drawn this binary number which says first 0, then it has a transition from 0 to 1, and then it has a transition from 1 to 0 and again from 0 to 1. Basically, this question is on pairs of transition. That is the count of how many transitions are being there. As in first we got 0, then 1. So here I got my first pair. Then when it goes from 1 to 0, there is again a pair. As it is flipping from 0 to 1, then 1 to 0, and again we got 0 to 1. So in this case, we got 3 pairs of transition, or we can say 3 flips. Let's understand this by iterating one by one. Firstly, the arrow is on my first digit, or I can say most significant bit, and we will keep iterating towards right. So as soon as I go on the second bit, there was no transition, there was no flip. But as soon as I reach on the third bit, there was a transition from 0 to 1. That means I got my first pair. After getting my first pair, I'll be moving ahead. Again, as soon as I reach on the next bit, there is again a 0 which is having a transition from 1 to 0. So there was another a pair. So here I got 2 pairs till now. Then again when it reaches 1 from 0, there was again the third pair. So in total there was 3 pairs of transition from 0 to 1, then 1 to 0, and then 0 to 1. This is what our question is looking for. Let's take for one more example. Here I have 0, 0, 1, 1, 0. If I draw it, I can understand this clearly that there was no transition over here, but as soon as it reaches from 0 to 1, I got my first pair. So I can say pair is equal to 1. And then when it reaches the other one, there was no transition. Again, when it goes to 0, I got my second pair. So 1 plus 1 is equal to 2. So in this binary number, there were 2 flips. First 0 to 1 and then 1 to 0. Now let's implement this so as to have a clear understanding. So I'll go to PyCharm, and here let's start making function def. Here we are counting the number of flips. So I can say count underscore flips, and here I'll take bits in my arguments. Let's define bits here only. So I'll write bits as of now I'll take the same one, 0, 0 and 5 by putting comma. At the same time I'll call the function also. Now let's start writing the program. Firstly, I'm looking for pairs. So here let's initialize it with the flip variable. So flip is equal to 0. Initially I'm saying there was no flip. Then I will start iterating from first digit. So here I'll write for I in bits. And here I am on 0 state. Let's change the pen ink. Yeah, I am on 0 state. So for checking that I haven't received any pair or it is in 0 state, I'll put the condition if flip divisible by 2. If it is divisible by 2, that means it is in 0 state, and then if I get bit to be 1, there will be a transition. So here I'll look for if I is equal to 1, my flip will be incremented by 1. Else, on the other way, if I am on 1 state, then also if the on the right bit or the bit on right, if it is 0, then also there will be a pair, there will be a flip. So here I'll go out and in else part, on the other way, if I is equal to 0, because right now my flip will be on 1 state, and as soon as I get 0 state, my flip will also be incremented by 1. Or I can define it as pair as I did in the open board, and then I'll return flip. Let's call the function. Here I need to make print so as to get count of flips. So when I run the program, here I got 3 for 0, 0, 1, 0, 1. I got pair is equal to 3, or I can denote it as flip also, because there was a flip from 0 to 1 and 1 to 0, and that is the thing we are looking for in this question. So this is it. This is how we can count the number of flips in particular binary digit. Hope you understood this question. I'll be coming daily with such nice concepts and with their easiest solutions. So don't forget to like, share and subscribe my channel. Thank you.